say primarily they're a mobile developer? Anyone? OK. I suspect in 6 months that will be like 3 times as large. Yeah, hopefully, seeing the trends. Let's see here. I'm going to go out on a limb and say, who here would say primarily they're JavaScript developers? OK, cool. And then the other one I'm really curious about, out of everyone, just who programs stuff on the server? OK, cool. So it looks like there's some nice cross-training, cross-cutting stuff going on. That's cool. So I think you'll like what we have to say tonight. My name is Seth Ladd. I'm a developer advocate, as Peter said. I work on the Chrome team, specifically focused on Dart. Just a quick background about me. I grew up programming Java. My first language was C, but I really like Java because it's the first language at that time for me that was garbage collected, kind of developer-friendly at the time, but it really embraced the browser. And this was cool. I mean, certainly at that time it was applets. Of course, that didn't work out, but there was this great thing about it. You could load code over the network. You could load the bytecode. It had proper classes for, say, URL classes or connecting HTTP resources. It really, really was started to understand that there was a network there involved. And so for that, I was all over it. Of course, Java got relegated to the server, where I spent a lot of my time, and then moved on to Ruby on Rails because I wanted to actually be productive. But then I was lucky enough to get this great job at Google in the Chrome team. I was not a JavaScript ninja. I'm the first person to say it. And so while I quickly fell in love with the awesome HTML5 platform and modern browsers and all the awesome stuff that's going on there in Chrome and Firefox, et cetera, the whole time I was kind of missing something. And I realized it was my expectations in terms of the development productivity and happiness weren't quite being met. I was productive in one sense, but I missed things like toolability. I missed things like being able to refactor. I thought that was important. I missed things like code completion. I missed things like an editor that could tell me if this particular line of code was wrong because it understood the rest of the program. I missed my classes and interfaces and packages and libraries, et cetera, et cetera. And so when I heard about this great Dart project, I jumped all over it because it allowed me to program the browser and the modern web, which to me is the most exciting platform out there, with a language, tools, and libraries, et cetera, that really meet and exceed my expectations. So hopefully I can show you some of that. But that's actually going to be a small part of my talk. What I really am excited to show you guys is the work going on in the web platform itself that indeed Dart does build on top of, but that's in terms of web components. And so just like I like classes and libraries and packages for encapsulation and modularity, it turns out that the web has actually been lacking that for, well, forever. And in order to scale up, in order to encourage more sharing, in order to develop more interesting applications that meet and exceed our users' expectations, we know that we need to actually build in some sort of component system or some sort of widget system for the web. So you can encapsulate things like styles, behavior, structure into these reusable components, share them, extend off of them, build them. And if you put this functionality actually into the browser, then we all see what happens when the browser itself launches with functionality as opposed to libraries that you have to go download and integrate. Really amazing things start to happen. And so I'm pretty stoked, and hopefully I can show you some really cool stuff. OK, let's move on. OK, so obligatory demos. The web is awesome. There's a lot of great tags. What the web does not have is Gangnam Style. So, music. All right, OK. That's going to get old, but it works. OK. OK, so I could probably do this by cobbling together a bunch of CSS and JavaScript, et cetera, et cetera. But what are we looking at here, right? Here's an actual tag for Gangnam Style. Now, of course, the web doesn't ship with this. But here we are with an actual tag. Like, that's just a slide. So, yeah, whoa, OK. Let's go ahead and inspect the element here. And sure enough, you probably can't read that. So sure enough, once I zoom in. What's there right there in my page but X Gangnam Style? Wow, so that's cool. So I'm actually in my DOM. I have a tag that I've made up or possibly used from somebody else. And we'll see how we can make this later on. But that's cool, and that's what we're talking about. Of course, you can not just create arbitrary tags that do dancing Android robots that play sound. You can also extend existing tags. So here's a good example. The thing that I've always wanted to do ever since I've been programming the web is extend button to create fancy button. It is crazy today that you can't extend button. But thanks to web components, you actually can. And I both mean it semantically extend, but also behaviorally in actual implementation. So here's mega button, which itself is a button. So let's go ahead and try to click this. Whoa. So of course, you can embed your own functionality. Yes, and it moves. But this shows you that you can extend actual button to create new buttons, extend their look, behavior, add multimedia, etc. This is the kind of things that we're talking about. And I envision a world, hopefully in the not too distant future, where we can stop developing web apps like what's on the left. This is how it's done today. This is actually Gmail. And if you look in here, there's just a billion divs, right? And there's no semantic information in this whatsoever. There's nothing useful to web crawlers. There's impossible to debug by hand, right? Because if you want to go into the dev tools to figure out what's going on, good luck. And what I want to see, and what I think everyone else wants to see, is what's on the right. In Gmail, what is it? It's a collection of messages. And what does a message have? But it has a subject and a body and a sent on date. This is the interesting thing. This is semantically relevant. This is easy to parse, grok, understand, share with other people, not the version on the left. And so what web components will help bring about is this declarative renaissance to web development, in that you can just simply say what you mean and stop worrying about div soup. Now, of course, under the covers, it might be implemented with a bunch of divs. But that's an implementation detail, much like you might write a class that exposes an interface but hides the implementation details. The consumers of that class, of course, don't care like what's going on in the covers. Nor should the consumers of your web app care about the 50 million divs and spans you got to create. Just get that thing to align. So I think we can all agree that the version on the right is what we should be aiming for. Hopefully we agree. OK, so let's talk a little bit more specific about what web components are, because it's kind of an overarching term that really encompasses a few different aspects or standards or specs. So let's break it down. The first one is a new tag, a new element called template. This is really the scaffolding or the blueprint. The neat thing about the template is it's inert chunks of DOM. And what I mean by that is you can define now real DOM elements, divs, spans, bodies, well, not bodies, but buttons, et cetera, wrap it in a template. Now your browser's like, OK, so that's a chunk of DOM that you're going to want to use later. I'm going to parse that, but I'm not going to do anything with it. But now that you have a real document fragment, you can reuse these things and build with them, and it really becomes the blueprint. Now, we have this concept of shadow DOM. The shadow DOM allows you to take these templates, or programmatically, a bunch of nodes, and insert them as the implementation into another node. And so we like to think of it like the mortar or the glue. And we'll see examples of all this stuff. But with the shadow DOM allows you to take, OK, I've got some chunks of DOM here, and I want to slide it in and make it implement this other DOM node that you have actually in your document. And then finally, the one I'm most excited about is Element. This is your custom elements. Elements builds on a bunch of stuff we're going to show, including shadow DOM and template and others, for the actual tool belt. You can create new HTML elements. You can now add to the lexicon of your web app. This is phenomenally powerful. So just like you can in your app introduce new classes that express new behavior and encapsulate ideas, you can now do this when you're programming first-class web apps as well. OK. By the way, if you guys have questions, just raise them up, and I'll do my best to answer. So let's get started and look at templates. Let's dive in. What are they all about? So amazingly, template's not a new concept, OK? And this is going to be a common theme tonight, is that a lot of the stuff we're talking about is actually not new in terms of we're just paving the cow paths or making what you guys want. And this is probably just going to get weird after a while. What you guys have been wanting to try to do various number of hacks or libraries, et cetera, and bake it into the platform. So hopefully it eases the barrier to entry. OK, so again, not a new concept. What have we been doing up to this point? Don't we have stuff to do templates? Well, method number one, off-screen DOM. OK, so of course you can create whatever you want, divs, and hide them. And they don't show up, but they're still in the DOM. And you can go grab them, et cetera. But there's a couple issues with this, right? The first one is the DOM that's inside, or the children of the node that you want to hide. It's still completely interpreted by the page. So images are loaded. Scripts are parsed and possibly run. That's not what you want when you want to have a pure template, which is to be instantiated later. And think about performance, especially in mobile. If you have a lot of templates with images, when you load up the page, you want to first go get all those images, right? So that's kind of a problem. And there is absolutely no encapsulation. This, to me, is as big or bigger of a problem. There is no boundary at all between the elements in there that you may want to, say, style. and the rest of the elements on the page. And one of the themes here is encapsulation. There's no encapsulation here. OK, yep. OK, also not good. OK, old school templates. So this is what some people do today. You can put it inside a script tag. But to me, this is a complete bastardization of what the script tag was meant to do. And so that really rubs me the wrong way. And we're also doing a lot of runtime script parsing. And if I can do anything to avoid script parsing, I want to do that. Here's a good example to show why script parsing is always not the right thing to do. I remember a day when the mobile Gmail app actually took its JavaScript and put it inside comments in the head of the page to avoid the initial scanning and parsing of the script tag on initial load. Because what they found, the slowdown was simply parsing the JavaScript. And so this is why I don't like this, because it introduces performance problems. OK, so we have a solution thanks to web components or the family of specs. That's the template tag. Now, we've already mentioned it, but this is proper templating. Here's an example. Again, if the web platform has these kind of baked-in things called elements, let's go ahead and take advantage of that, which is another good common theme here. So we're going to introduce a new element called template. And inside, it is parsed by the rendering engine, but it's not implemented. It's not interpreted. So it is still DOM. We're still working with DOM. And we declare it via DOM. But we can go ahead and say, grab it later programmatically. And once you've grabbed it later, you can do great things like clone it over and over, insert it, programmatically work with it. Again, just using the functionality of the browser already, like query selector and append child and all that. It's just that we're working now with semantics of an actual template. And you can see here that it's simply just treated. You can think of it like a document fragment. Again, something we're probably already familiar with. So I'm really, really excited for templating. It's such a simple concept, and it allows you to do really powerful things. Question? So stick with me a little bit, and we're going to lead up to custom elements. And I think some light bulbs will go off. In the most raw, sorry for the video, everyone. The question was, is this compatible with jQuery? In some sense, the answer is definitely, because what we're simply talking about is JavaScript and DOM nodes. So if you can program JavaScript and access the DOM, then you're going to be fine here, and jQuery will work with it. However, this is a building block for real, reusable, customizable elements. And in that case, you may not need so much of jQuery anymore. But we'll see that. But good question. So we think this is pretty money. I think you guys should too. Moving on, though, shadow DOM. Now, you have these template nodes, and you can insert them straight away. But what we really want is a more way to kind of slide in and implement nodes using other nodes. And that's where the shadow DOM comes up. So it turns out that the browsers actually sort of had this concept already. So let's give an example of this. OK, here's an HTML5 video tag. We're all familiar with that. Bracket video, you give it a video. OK. Now, you might be thinking that, OK, so some C++ code renders the UI here because that's how browsers do stuff. Well, it turns out that browsers lay things out with HTML and DOM. So if we actually go, here, let me just right-click on this, inspect element. Aha. Here's the video tag we all know and love. But we're going to open this up. And lo and behold, the dev tools of Chrome is showing us that there's this thing called the shadow root. Now, inside the shadow root, now we see more nodes and divs. And what this is actually using the primitives of the browser, actual DOM, to implement the UI of the video tag. Now, of course, why don't I see all these divs and input buttons and right inside my DOM here normally? Why do I only see the video tag? Because it's hidden inside something called the shadow root. And this is where the shadow DOM comes in. And I'll show an example of that. And this manifests itself in many ways. The date pickers and the time pickers, the video tag, these are all actually implemented with HTML under the covers, just encapsulated, thanks to the shadow DOM, under the tags that we are normally familiar with. So let's try to, encapsulation, not a new concept. OK. So what's going on? And I have this fancy thing here. OK, great. So here is the DOM tree that we're kind of familiar with, right? This is what if you go into DevTools, you'll see a tree of nodes. And just like we saw, there was a video element in there. But we also saw that pound shadow root. The shadow root pointed to this other shadow nefarious DOM here with its own tree and its own children, children, et cetera. This is the implementation of this node right here. not these guys. I mean, these are straight up regular old, if this is the shadow node, if this is the shadow root, maybe this is like the light DOM, I don't know. But these are the nodes you would see if you were to like go into jQuery or the DOM and say, walk the tree. You're going to see the green nodes. You won't see these pink nodes because they're the encapsulation. These are encapsulated. They're the implementation detail. So the real element in the DOM, the video tag here, is what shows up in the DOM, but what is rendered is the nodes or the shadow DOM itself. Does that all make sense? Like that, when we saw that shadow root, OK, I see some nods. Those are the implementation details. That's what's actually rendered up to the UI. But in terms of walking the DOM, in terms of going into DevTools and seeing what nodes I have in my page, you only see the green nodes because you want to hide those encapsulation details. Shadow DOM allows you to hide the details, which is great. So how do you do this? Well, first you can start with a just programmatic create a shadow root. And you can do this off of, as far as I know, almost every element. And once you have a shadow root, it itself just being like a DOM element, you can go ahead and do normal stuff like you would with any DOM, like inner HTML. And then what you see here is, yo, you got replaced. So let me break. Actually, I don't need this. I got this. Let's show you what's going on. Here we have a div ID host. And it itself has an h1, my title. So just focus on this. Then we want to go find the host element, which happens to be this guy. We're going to create a shadow root. We're going to create elements off of the shadow root. And once we attach the shadow root to the host, it is going to completely change the implementation of the host element. Notice how down here you do not see my title. You don't see my title here. You see the elements from the shadow root. And that's what I mean by the implementation details. OK. Now, ironically, I realize this is the most unstyled slide in this whole presentation. I don't know how that happened. But what are the benefits of the shadow root? Well, certainly you can hide implementation details in terms of DOM elements, right? We've shown that. But it turns out there are also great encapsulation boundaries for styling as well. And by styling, of course, we mean CSS. So what's going on here? Same example from last slide, except in this one we add a style tag. And in this one it says the color is red for H2 elements. Excuse me. Now, of course, I have other H2 elements on this page. Why aren't they red? It's because the styles that I add to the shadow root, and of course, the shadow root's children, are only applied to the shadow root and his children. So now I have this great encapsulation boundary for styles as well. This is fantastic. You can now ship components that encapsulate their structure, thanks to the shadow DOM, and now can encapsulate their styling, thanks to just the implicit rules about the boundaries of these shadow DOMs. Yes?
So if you wanted to have control, if you wanted to give control of styling to the outside.
You are awesome, because this is where we're exactly right there. Yes, because you can sort of kind of fake, maybe if you rewrite all your CSS selectors to be really explicit off of some ID and you have like a CSS processor, you can sort of fake that. But what you can't do is like interlace and give explicit control to the designers to be like, you know what, I must style my H2s red, but I want my widgets to look like your widgets, and so I'm going to allow you to set the font. With Shadow DOM, you have that level of control. And so here's an example of it. And oh yeah. OK, so we're setting the style. And then there's two properties here that I want you to take a look at. Reset style inheritance and apply author styles. And both of these are properties off the shadow root. So we're going to click reset style inheritance. And what does it do? From my read on this, it is saying, I'm not going to inherit the browser's base style. So notice how I kind of go back to like old school Times New Roman there. But it's cool. If you want 100% complete control, go ahead and flip that flag. Another one would be apply author styles. And now when you can start to let the author styles from the page bleed back in. And notice how now I'm getting the font from the outside page there for my internal Shadow DOM. So you've got these levels of control. But it turns out you actually have more control. There's a couple things you can do. You can even have CSS rules for the host element itself. That's the element that hosts the Shadow DOM. This is an example here. So we've got a selector here at host. You can say, and this comes up all the time, you want to shadow the thing that you live inside of. So you can do that. And this is where it gets really cool. And it turns out, again, browsers have been holding out on us. Here's a slider. So this is straight up HTML5 element, right? And many people might be like frustrated because I can't make that look like my site. But it turns out if you go read this source code, that many browsers implement pseudo selectors for these specific, for these specific input fields. So WebKit slider thumb, you can go in and style it. And so you can do really fancy things. What are we doing here? Make it red and blue, or make it cool and shadowy. So you can actually do this today if you are like in the cool club and you happen to know these esoteric, hidden, completely non-standard pseudo selectors. But the idea is great, right? Again, with encapsulation, I don't want to expose the inner structure of my shadow DOM, because I don't want the people consuming my elements be like, oh, the div of the span of the H2, because those are all implementation details. I, as a developer of the component, want to simply say, I'm going to give you a pseudo selector, and you style that. Don't worry about if it's a div or it's a span inside a div. But you get the same effect. You can give these kind of styling hooks as the author of a component, and then the consumer of the component can style the pseudo selector here and get that level of control. But the author of the widget gets to dictate how much control you give. Much like if you were developing a class in any of the structured programming language. You can expose things as public or private and expose as much or as little control as you want. You can mark a method as final, it can't be overridden, or not, and it can be overridden. You have the same level of control with styling thanks to these pseudo selectors. But we can do more, we can do better. Another hook you can provide as a widget author is to offer variables that can be given values by the consumer of your widget. So here's a good example of this is the shadow, This is the shadow DOM CSS. That is, this is the CSS as a widget author, I would say. So I'm going to say, okay, the color is set by some variable, button text color. The consumer of this widget here simply defines that variable, and it works. Whoops, sorry, didn't mean to go there. So it's yet another way for you to say, OK, I'm going to let someone define the values for these variables, and then whatever they define it, that's what it's going to take. So yet again, more opportunities and hooks for you to define very fine-grained the level of styling control you want to give to the consumers of your widget. OK, so shifting gears a little bit, if we remember back to the template and the shadow DOM, if I take a template and give it to a shadow DOM, it completely wipes out whatever nodes were in that original host. And that's kind of a problem. I mean, maybe the implementer of my tag, that H1 was really important. Well, it turns out that, let's make the next one here, that when you write with the shadow DOM, you can create or define insertion points. So I like to think of this like an interlacing mechanism, where you want to expose the UI generated by your shadow DOM, the nodes in pink, but you also want to put kind of placeholders. You want to say, OK, I'm pretty sure I know most of the structure here, but I want to grab a node from the host document and put it here. Then I want to grab another node and put it from there. So it allows you to pull in content from the host node and inject it into your shadow DOM. So what happens then is here's the node that actually shows up in your DOM. Here's the shadow DOM as defined by you, the widget author. And then here is the DOM nodes that used to be under here. You've pulled them down, and you've inserted them in at the right points. And this is great, too, because sometimes the interface between your component and the rest of the world is simply other DOM nodes. So for instance, you might think of like a commenting widget, a comment field widget. And the comment field might be like, you'll take care of the details of showing the comment, but you want the name to come in from the host page. You could do that. The interface is really just the DOM nodes you insert. So here it is in practice. Here's the host node. We've seen this guy before, right? Simply div h1, h2. Now, previously, remember, the h1, h2 here, my title, those were erased from existence. But over in your shadow DOM, if you say, well, I want to pull some content out of my host node and insert it, these are the insertion points. Now you're interlacing the nodes and elements that you've declared in your shadow DOM with the nodes or elements. Whoa, that just went orange. Here, disable. With the nodes and elements that come from your host node. And now this is really cool. It's a way to, again, interlace the structure of the host document and yours as well. And you can see right here, here's my subtitle, which comes from this H2. Whoops. You've got enhanced, which comes from the shadow DOM. My title, which comes from the H1. And that's this guy right here. And so on and so on. So it gives you a lot of control and allows you to give to the consumer great injection points, if you will. So that's cool, too. We think that's pretty cool. Yay, animated GIFs. OK, building on top of all that stuff, how we doing? Yeah, OK. Custom elements, putting it all together. This is where the rubber hits the road. This is what you guys will be working with a lot. So it's all about encapsulation again. The custom elements let us encapsulate the structure, and that's the template tag. It allows us to define inert sets of DOM nodes. The styles, we saw that as if you define style tags inside a shadow DOM, they only apply to the nodes in the shadow DOM. And the behavior. So it's one thing to create declarative web apps that just sit there on the page, but of course it gets really cool when you give behavior to these new elements and give them a programmatic API. Wrap it all up, and you can define your own actual elements. So how do we do it? Well, again, embracing the functionality you have in the browser already. The browser already defines, well, you can have tags, so let's create a tag for element. And the tag for element has a name, and that name is the tag that is the name of the element that is being used in the page. And what does the browser platform already provide? But links, much like you might link to other CSS sheets. Why not just link to other custom elements out there? And so you can do that too. And here's a very simple example of a simply custom element that just defines some structure. Question in the back.
That sort of reminds me of AngularJS.
So the question was, it sort of reminds me of what came from AngularJS. Yeah, you wouldn't be too far off from that observation. I think there's a lot of great cross-pollination between these different efforts. But one major distinction, and we'll see some more neat stuff that's even closer to Angular in a little bit. But one big distinction is what we see here today is stuff that's landing in Chrome and is on the standards track. And so you look not convinced by that.
It seems like, I mean, you're saying that one got approved and the other one did not?
No, cross-pollination. Like, it's great. Influence is taken from both. The teams talk. It's really, really cool. And so what we can do is we can say, here's some really good ideas. Angular is a source of really good ideas. And if we codify them into the web platform, now that means just like if you ship a video tag in the web platform, you don't need a plugin anymore. If we can ship functionality like reusable components and a templating system, and you'll see later other cool stuff, into the web platform, now everyone has it if they have a modern web browser. And I love to see stuff like that happen. Another good example would be some of the stuff that jQuery did. You saw end up in the web platform, now everyone gets it. And that means that fewer lines of code that need to ship over the wire because you get it for free. And that's always a good thing.
That would work across.
So again, the stuff we see here today is on standards track. The feedback we get from the other browsers is very, very positive. And this is actually production Chrome. This is stable Chrome. So this stuff is being landed and tested in the wild. And so I'm very optimistic. Question? Yes?
So how do you handle tag collisions? Are you going to talk about that later?
No. That's a great question. There's no concept, as far as I'm aware of for namespaces. So, OK, I got to zoom ahead a little bit, I think. Sorry, guys, skipping. We'll see this all. OK. So this is all good stuff. Hopefully you want it, you demand it. And some of this is actually in Chrome today. Chrome 25, latest release, awesome. But there's another option to bring this stuff and more across the modern web today while you're waiting for the browsers to land this stuff in their version. And why talk about one exciting feature when you could talk about why not two? And that's where Dart comes in. And I wanted to show a couple quick slides about Dart before we get back to the web component stuff, just so you guys are in the right space. First thing to understand is Dart is not just a language. It's the libraries. It's an editor. It's a compiler to JavaScript, which is very, very important to understand. It's a very familiar and structured language. But what we're going to show today is how it can allow you to compile down the web component stuff to vanilla JavaScript and HTML, which you can deploy today. Because hopefully you were excited by the stuff we saw earlier, but you shouldn't have to wait for it to land in every browser before you use it. So the question we always get is, why Dart? And the answer, hopefully, is the screenshots in the background, which is we want more developers to build more complex, interesting, feature-rich apps for the modern web. Frankly put, it's too hard to build Photoshop in the browser using the stuff you get in the browser. And I want to do better than that. It's too hard to do apps like this. Really complex UIs and UML rendering, Photoshop's in the background, really slick touch-based mobile apps, CAD rendering. This stuff should be shipping in the browser. And it should be much easier. Like you wouldn't write Photoshop with Python, for instance. And so we want to provide something that's very easy and familiar for a whole bunch of different developers to come on and deploy to the most awesome platform there is out there. So I don't know how many people know Java, so we're going to skip over this. But here's just a quick syntax. This is not a language talk, but just so you understand what we're doing here. Here's a couple features of the Dart language that might be interesting to you guys. First off, very familiar. We have your curly braces and we have your semicolons, so do not fear. We have the keyword class. Again, not trying to break any new grounds here with syntax. We got a little flack when we launched Dart. People were like, why didn't you build the next Haskell? And we were like, we want more than 5 users. And so we, we built something that everyone that we've seen so far jumps into very easily. But it doesn't have to be totally one-for-one copy. One of the nice things is when you build a new language, you can say, fix some of the verbosity that everyone always does. So what's something you always do in constructors? This dot x equals x, this dot y equals y, etc. Well, in Dart, if the constructor parameter is the name of the field, you can simply say this dot amount, and it will set this dot amount equals amount for you. Nice. Why don't all languages do that? That is cool. OK, named constructors. Now, of course, in statically typed languages, you can overload the constructor based on the types of the parameters. But Dart and many other dynamic languages are optionally typed, or they don't have types at all. So you're kind of stuck with constructors, and then you have to make factory or static factory. But in Dart, you can actually create named constructors. So you can simply say new money.fromDouble, which is great because then think about this use case. If you get a string, it could be either XML or JSON, and you want to say populate a person object. You can say new person from XML or new person from JSON. So it really reads really nicely at the call site. Let's see here. We also have optional parameters. That's what the curly braces are. And if you have an optional parameter, you get a default value. So that's very cool there. Operator overriding. That's a pretty great feature. I love that. Fat arrow syntax for one-line functions. That's in there too. What am I missing? Anything else? Some pretty straightforward stuff, but with the niceties I think you might expect. Other cool features, really quickly, I guess. Lexical this. This is a trip up in JavaScript a lot, so we try to fix this here. Whoa, we didn't fix this. OK. But here you have a click handler. And in JavaScript, what would this do? Anyone need to know? If you had a click, you put in a callback inside. This would be like, I don't know what crank the awesome is, because this in JavaScript would be the button and not the object in which you define the function. But in Dart, you have lexical scoping everywhere, but you also have lexical this. And so this code reads as if you were to give this to anybody, and they were like, oh yeah, it's going to call this method down here. So that was a nice thing that I think we cleaned up. I'm trying to zoom through this to get back to the web component stuff. We have optional types in Dart, which is great. And so, of course, you can write code like this if you want. And this is often pretty good when you're just getting started. But as you solidify in your design, you probably want to add type annotations to give clear intent to both the machine and your fellow developers. And once your machine has the clear intent, it can actually give you this real-time feedback. And so Dart is statically analyzable. So of course, if you type a method that doesn't exist, it's like ding, ding, ding. You should probably change that. And then you can also get code completion, all these great tools. So let's see if I can. Sorry, I'm going to skip through some of this stuff. Time? I'm really paranoid. OK, great. This one I should probably show you. Really important is that Dart compiles to JavaScript. Critically important to everything we do. So let me show an example of that. So let's go into the Dart editor. I'm going to show a couple things all at once. Here's a simple app that I have imported 3 different packages. And yes, Dart ships with a package manager because we have formal libraries. And oh, the editor is telling me that I don't know where those are. So let's use the editor. And you can do all this on the command line. So don't worry if you don't like editors, that's fine. Although they're really helpful. They tell you things. OK, so it went out into the intertubes, and it went in and downloaded the packages, symlinked them all correctly. Ta-da, it's all working. And notice I've only written like 7 lines of code here. And the majority of my stuff is actually third-party packages I've never seen before. All right, so let's run this bad boy here. Let's run it as JavaScript. Right now, it's compiling to JavaScript in the background. And of course, you want to see some cat pics. That's so cute. But what's the important thing here to know? The cat pic is a package, a third-party package. The widget is a third-party package. The frame is a third-party package. And when you have libraries and classes and interfaces baked into the language, and you ship a package manager, you can actually have code that all just works together. And it's really, really cool. But the neat thing is, this is a Dart app running in regular Chrome, which has no idea about Dart otherwise. So another neat thing you can do when you compile to JavaScript is, let's just pull up a demo here. OK, so this is some of the demos that got shipped with the Dart editor if you want to play around. We're going to run this as JavaScript again. OK, compiling to JavaScript. So that's pretty fast, not too bad. Neat, solar system. OK, so you might be thinking, great, but how do I debug these things if you're compiling to JavaScript? Well, it turns out we generate this cool thing called a source map. And let's go in here. And the neat thing here is in DevTools. OK, so point number one, this is DevTools, and you're seeing Dart code. Now, of course, DevTools or Chrome doesn't know what Dart is. So how is it mapping the JavaScript to Dart? Well, that's where the source maps comes in, which is cool in of itself. But let's do this. Now I can set a breakpoint, just like you would in regular JavaScript programming in your DevTools. I can set a breakpoint in my Dart code. And thanks to source maps, it's mapped that line of Dart code all the way into some line in JavaScript down here and stop the execution of the JavaScript. And which, just like you would, I think, debug any other app in JavaScript. And we can open this guy here and all that stuff. Let's see, keep an eye on this sun here. So if we skip through this, right, Mercury. So you get the stepping, you get to set the breakpoints. Even though you wrote Dart in the first place, you've got that great connection between the two worlds. So that's pretty cool. And this is just about source maps. And so this is not just a Dart thing. Source maps you can get from Clojure Compiler. I think Wit does this as well. Very, very cool technology. We are not using the Clojure Compiler.
Are you getting ideas from the Clojure Compiler?
Funny enough, the very first version that we wrote of the compiler to JavaScript, I think had a lot of Clojure Compiler stuff, if not actually used it. And it generated very large amounts of code. So now we have a Dart to JavaScript compiler written in Dart that does complete holistic program analysis. And actually, it's a great segue into this, which has this really nice benefit of tree shaking. So one thing when you statically analyze your application, well, let me back up, sorry, and then hopefully it's another reason why we did that, maybe to answer your question. What do you do today when you talk about JavaScript? You look for very small libraries. Why? Because the number of bytes over the wire is very important to worry about. Of course, that's important. But what happens is even if you go from like jQuery to Zepto to literally, I think Jojo is called Nano, and then probably Femto is coming out at some point. But you're still paying the incomplete library tax when you pull in those libraries into JavaScript. Well, it turns out that in Dart, because it's statically analyzable, we can actually generate a version of your program that is tree shaken or eliminates the code that you don't call. So now you no longer need to worry about the size of libraries. You simply need to care about, does this library do what I want? Because even if you import an entire library over here, but you only call one function from that library, the tree shaking compiler, which the Dart2JS does, will simply include only the nodes from the AST that are actually used in the program and prunes all the dead code. We should all be demanding this totally awesome bit of functionality here. Any library you want to link into your Dart program.
So jQuery, plain vanilla.
No, we can't do it with JavaScript because JavaScript is not statically analyzable. It's too dynamic for you to be able to make these calls. For you to be able to pick up the program by main, see the AST, and all the actual structure of the program is not apparent in JavaScript unless you run the program. But in Dart, you can do that because it's a structured language. And
You can only tree shape Dart code.
that's correct. Yes, good question.
Reverse engineer JavaScript.
Yeah, sorry, hit me up after. Our performance is pretty good. OK, I probably have like 5 minutes left, and so let's bring it all the way back to web components. Dart and web components actually go really well together because Dart is a very structured encapsulation language, classes and libraries. Web components, structure, encapsulation, reusable widgets. So thankfully, we have a compiler to JavaScript. And so we can also compile your web component code to vanilla JavaScript and HTML as well. And we can do that without sacrificing developer time. And I'll show that here before I got to get off for John. OK, and this is probably the most important part. The reason why we do this is to bring this functionality of the new web component type specs to all modern browsers today. OK, let's see some demos. Let's go back to the Dart editor and load them up and see how fast I can get through these guys. Let's first see the simplest, most simple example possible, hello world. Now, this is Dart code. Now, this brings it back to Angular, right? Now, this is how the web UI library in Dart works. You can create, let's see, data bindings, live two-way data bindings with the double curly braces here. And whatever this superlative variable is value will be printed there. You can also declaratively create event handlers. It's all done in the DOM. And we actually compile all this down. We have our own HTML5 parser that spits out all the compiled code. Now, we're going to load in hello world.dart. This is the functionality of the app. Aha. Now here's that superlative. Okay. And notice how I've marked it at observable, which says, hey, I want to watch this variable. Anytime this variable changes, fire off all the events so that the live data binding works. Here's that change it function. And what you're seeing here is all top level stuff. So Dart's really cool. You don't have to put everything in classes. This is just, it all works. When the button is clicked, change it is run. It simply grabs an alternative and sets superlative. But what you don't see anywhere in here is like, go fire an event or go find that element by ID and set its value. All that's taken care of simply by the declarative nature of in here. So just to run this, just to show. Okay, well that's in Firefox. Just to prove that it works on the browsers. So of course that works. So that's really cool. So I compiled the vanilla JavaScript HTML, works in multiple browsers. You get the same declarative nature that, say, Angular has really promoted. But we can go farther as well. And sorry, I'm really out of time, but if I have time, I'll answer your question. Yes, this is a metadata bit. But the web UI compiler looks for this, and he puts in all the code to wire up all the events for you. Yeah. So I'm going to show a couple of things kind of in quick succession, and I'm happy to afterwards show you guys more. We've got great iteration functionality. So remember, that template thing is now back. So we talked about that. And now I can iterate over a collection of features, so feature and feature, and actually bind that back down into the template itself via this two-way binding here. So that's iteration. Conditionals works as well. Let's show you that. Here we go. Only render the div if lang choice is not null and lang choice is not empty. So I have conditionals, I've got data binding, I've got iteration, but this gets really cool when we talk about custom elements. And so let's show you an example of that, because that kind of brings it all together. And this is really where the web components really start to shine. So here's a ludicrously simple to-do app. Sorry, I'm zooming through this really quick. But here we go. We're going to iterate all over to each individual to-do item. And for each to-do item, I want to render out li tags. But inside the li, I want to use a custom element, x to-do item. So where's that defined? So let's go check that guy out. Here we go. Here's an element tag. This is x to-do item. He's encapsulating the structure of x to-do item. Oh, he's got a label, and he has an input and span. Again, the implementation details. Nobody needs to know this stuff. But he also has some behavior as well. And this is Dart code right now. And this is really an MVVM pattern, modern view model. In that here's the view model, which is the code that backs your custom element. But itself has a to-do item, which is your actual business logic. Right? You actually probably have some data object like to-do or person or account. So you're going to give one of those to your actual component. And notice how I've got methods that can bind to these events. And let's see here, just to prove this all works. OK, so I'll run it in Dartium, actually. This is a build of Chromium with the Dart VM, which we find is really slick when you don't want to, say, wait for compilation. Downloading proxy script. Whoa. OK, so simple learn Dart. Now, this is great because, again, I didn't have to write any code for go grab the document fragment and like copy it a bunch of times and insert it every time I click that. I didn't have to write any code for, OK, listen to the button, and on that event, go over here. Those are all declaratively stated, thanks to those data bindings and the double curly braces. And then this here, the label, the fact that it can change its CSS class, the input checkbox, that's all encapsulated inside x to-do item. So you can imagine, as developers, we can create these custom elements, ship them around to our fellow developers inside your company, outside the company, share them, reuse them, extend them. Just like you can do with any structured language, we can bring that to web development. That's pretty awesome. I'm pretty stoked for that. So, sorry I had to totally zoom through that. That's what I was going to show you, but I'm out of time. So, yes. I think that's it, because this was all the other stuff. So, summary, hopefully you guys saw the web components, the composable, reusable components. Actual widget system, well, you can build an actual widget system on top of this low-level functionality that's shipping in the browser today. And this stuff isn't Dart specific. The first whole half of the slide deck was just JavaScript stuff. But thanks to our polyfills, we can make this all available to you with vanilla JavaScript and HTML that deploys across the modern web, and with what we think is a nice structured language with classes and optional types and libraries and other stuff that helps you scale up your code from 10 to hundreds to tens of thousands to millions of lines of code. And that's what's required when we need to compete with native mobile, is apps that big and apps that complex. So we think these two things go really well together. Hopefully you guys can try them. This is all open source. It's all available today. And we love feedback. And I'll be around for a while. So thank you so much. I appreciate it. And enjoy the rest of the night. So the question was, I'm going to guess that you mean, does Dart ship with any components out of the box, like widget stuff? Yeah. So Dart does not ship with any components out of the box. But we really want the community to do a lot of this stuff for you. But I do want to show one thing I think you guys really like. You all know Bootstrap, right? Bootstrap's pretty cool. Who's sick of Bootstrap? I think it's actually really great. Somebody ported Bootstrap to Web UI, which is web components, and Dart. So yes, are there widgets you can reuse today? Oh, you can't see it anymore. Thanks. Are there widgets you can reuse today in a web component / Dart world? Yes, here's an example of it. And we are able to, here's a great example. X accordion, right? I mean, this is living the dream, right? Hopefully you guys can see that. This is how I want to work with the web. I don't want to create divs and divs and divs and give them special classes and then go pull some JavaScript that half of that code I'm not going to use. I want to actually say, no, I want an accordion, and I want that accordion to encapsulate its behavior. And of course, this works, right? Pretty neat. Hopefully you guys heard that. Can you create, let me ask the question another way maybe. Can I access my Dart code from JavaScript? OK. The question, the answer is I don't think so. Or maybe, but it's very, very hard. You can go the other way, though. We have a full JavaScript interop library. So you can write a Dart app that consumes JavaScript. And we have, I can show you Google Maps after this if you want. But one of the reasons why this is very hard is because, and this kind of goes back to a question around the closure compiler stuff. We've written our own compiler that fully understands the Dart world. So we can do great minification. You can do -- minify. We can go further because we understand the full program structure. We can do the tree shaking, all the stuff. But in exchange, in return, we make no guarantees about the publicly accessible API of that generated JavaScript code. Because when you minify and tree shake, the methods become A and B. And so you can't call into that from JavaScript because we don't want to retain those names. But you can go the other way. No. So the interop. So here's how we envision you actually do the interop. So again, you can access JavaScript from Dart. But if you want to go the other way, this is actually where web components come in. So you can build a component in Dart, and you can expose a programmatic API or a DOM-based API, either by setting attributes or inserting new DOM nodes. The DOM is like where it all lives. We're kind of looking towards the future. Yeah, it's very hard to get really great interop from JavaScript into Dart. So the question is, we ship with full unit tests that work on the command line and in the browser. We ship with a full mock suite that works on the command line in the browser. And we ship a headless version of Chromium called dump render tree. And so you can actually programmatically run all your tests on the command line, even in the browser. And there's this great CI service called Drone that just does all that for you. It's really cool.